Good morning, everyone. Today's lesson is about binomial expansion using Pascal's triangle. So what is Pascal's triangle? Pascal's triangle is one of the methods of expanding binomial. This gives us the idea of how many terms are there if we expand a binomial and what will be the coefficients in each term. Well, not really, technically those are the terms or this will be the terms, but it will help us answer or expand a binomial. And maybe you're thinking, oh, I need to memorize that in order for me to expand a binomial. Well, actually, we don't need to memorize this. There is a pattern exists in a Pascal's triangle. So let's say, okay, let's start with this. On the left side, you see all of these ones and all of those ones. So that's easy to remember. Next is we start from 1, we go down to the left, right, all right? We add 1, 1, that gives us 2. 1 1 on left and right, so that will be the coefficients of the binomial expansion if we erase it into 2. If we erase it into 3, 2 plus 1 is going to be 3, 1 plus 2 equals 3. You bring down those 1, so now we have the 1 3 3 1. And if we want to have the expansion for the fourth, or to the power of 4, just add 1 and 3, that gives us 4, 3 and 3, and that gives us 6, 3 and 1, that gives us 4, and of course the 1s and the 1. So it's not really hard to remember the Pascal's triangle because there is a pattern exists. All right, there is a variation of that, and that is if we have an x minus y raised to a certain power. Again, it's not also hard to remember. You see that net positive, positive, negative, positive, negative, positive, positive, negative, positive, negative, positive, negative, positive, negative, positive. So, and so on and so forth. All right. I'm going to give you 2 examples using to expand a binomial using Pascal's triangle. Let's go to the first one. Here, 5x plus 2y raised to 3 quantity raised to 4. And let's say, oh, I don't know Pascal's triangle, or I don't remember the coefficients that I needed in order for me to expand this. Well, again, if you remember the pattern, we start with 1 and then 1 and 1, right? You add those 2, that gives you 2. All right? So you add 1 and 1, that gives you 3 here, and then 3 here, and then 1, and then 1. So this is to the power of 0, to the power of 1, power of 2, power of 3. What we need is a power of 4. So add that 3 and 3, that gives you 6. Obviously, was this 1, 1, and then add 3 and 1, that gives you 4, 3 and 1, that gives you 4. So the coefficients that we need will be 1, 4, 6, 4, and 1. You see that? All right, so let's answer this. Let me erase this first. All right, here we go. So we will start with the coefficients 1, 4, 6, 4, and 1. And then from there, I'm going to consider this 5x. So there will be 3 rows here. The first row will be the coefficients using the Pascal's triangle. The second row will be based from the first term. So 5x, it says raised to 4. So I'm going to start with 5x raised to 4. 5x raised to 3, 5x squared, and then 5x raised to 1. Now, the next term, 2y raised to 3, you're going to put that on the right side of this. So that would be the third layer, by the way, and we will put that here. We will start here. 2y raised to 3 raised to 4, 2y raised to 3 raised to 3, 2y squared raised to, no, 2y raised to 3 square, and then 2y raised to 3 raised to 1. And then what we will do here is we will multiply each column. So 1 times 5x raised to 4, 4 times 5x raised to 3, times 2y raised to 3, and then 6 times 5x squared times 2y raised to 3 squared. I hope you can follow. So let's try the first one. So the first term will be the product of 1 and 5x raised to 4. So 5 raised to 4 is equal to 625 x raised to 4. So that's going to be the first term of the answer. Second term is the product of these three. So 4 times 5 raised to 3. We know that 5 raised to 3 is 125, right? So 4 times 125 times 2 raised to 1, which is 2. 2 times the answer to the first two numbers, the answer will be 1000. Next, let's consider the variable. So this will be x raised to 3, then y raised to 3, because 3 times 1 is equal to 3. That will be the second term. Let's go to the third term. 6 times 5 square. 5 square is 25, so 6 times 5. And then 2 times 2, or 2 square, that's 4. So 6 times 25 times 4 is equal to 600. Next, let's consider the variables. That's x squared. 3 times 2 is equal to 6. So this is y raised to 6. Next, let's go to the next term, the fourth term. 4 times 5 raised to 1. We all know that's 5. 2 raised to 3 is equal to 8. So 8 times 5 times 4 is equal to 160. X raised to 1 is x. Y raised to 3 is equal to y raised to 9. The last term will be plus 1 times that one. So 2 raised to 4 is equal to 16. Y raised to 3 raised to 4 is equal to 12. No, there should be a y there. So y raised to 12. So see, it's easier than doing it manually, like 5x plus 2y raised to 3 times, you know how it works. So let's go to the second example. This one is 2y squared minus 3y raised to 5. So we all know that raised to 4 gives us these coefficients, 1, 4, 6, 4, 1. So the raised to 5, or the binomial raised to 5, is going to be 1. So it's going to be 1, 5. This is going to be 10, 10, 5, and 1. Those are the coefficients that we need in order for us to answer the next problem. And of course, the signs will be negative, positive, negative, positive, negative. All right. So let me erase this, and then let's go to the next example. So here, there you go. Those are the variable, or those are the coefficients that we need. And also, those signs, negative, positive, negative, positive, and negative, they will also be the signs of the final answer. So that means here we don't need to worry about the signs of the final answer. The signs for each term. The first term will be positive, the second will be negative, etc., etc. So let's start again with the first term. That's 2x squared. So that is 2x squared raised to, guess what? 5. Okay, and then 2x squared raised to 4, right? And then 2x squared raised to 3, 2x squared raised to 2, and then it's just 2x squared. Next, let's consider this, and don't you dare consider the sign or include the sign. So we will just use the 3y there. So 3y raised to 5, 3y raised to 4, 3y raised to 3, 3y raised to 2, and then finally 3y. And again, what we will do is we will multiply each column. Let's start with the first one. 2 raised to 5 is equal to 32. X squared raised to 5 is equal to x raised to 10. So we are done with the first term. Second term is negative. So 5 times 2 raised to 4. 2 raised to 4 is 2 times 2 times 2 times 2, which is 16. So 5 times 16 times 3 is 240. The variables will be x raised to 8. 2 times 4 is equal 8, is equal to 8, and then y. The next term will be plus 10 times 2 raised to 3, which is equal to 8. So 10 times 8 times 3 square. 3 square is 9. So 9 times 8 times 10 is 720. X raised to 6. X squared raised to 3 is 6. 2 times 3 is 6. And then y squared. Next term will be 10 times 2 square. 2 square is 4. So 4 times 10 is 40 times 3 raised to 3. So 3 raised to 3 is equal to 27. So 27 times 10 times 4 is equal to 1080. So 1080 x raised to 4 y raised to 3. Next, plus 5 times 2 is 10 times 3 raised to 4. So 3 raised to 4 is 81 times 10 is 810. X square y raised to 4. And finally, that 3 raised to 5 minus 3 raised to 5 is 243 y raised to 5. So there you go. It's more straightforward. So I hope you learn this method because it's a lot easier to do this rather than doing the expansion manually. All right. Thank you for watching, and please do subscribe to my channel. Thank you.